All right, hey AP Chemistry. I'm going to be doing question 6 from your solutions entrance task. Now, this is going to be big, and we are going to do some notes on soluble ions, but there are only two things that are on this page that are not soluble. C and D are not soluble. PO4 3 minus forms insoluble salts. And calcium is not an exception. And AgCO3, Ag2CO3 is not soluble. And CO3 2 minus also forms insoluble salts. And silver is not an exception to that. If it was sodium phosphate, this would be soluble. If it was potassium phosphate, that would be soluble. But calcium phosphate is not soluble. Same thing with AgCO3. If it was Na2CO3, that would be soluble. If it was K2CO3, and you're going to see this in the lab, that's also going to be soluble. But AgCO3, Ag2CO3 is not soluble. And the Ag is not an exception. And you're going to see rules like that. Now, up here, we have PbC2H3O2 minus. This is soluble. That's because acetates, which is C2H3O2, acetates are all soluble, or they form all soluble salts, meaning they dissolve in water. And then this is also soluble, because ammonium, NH4, is another ion that forms all soluble salts. Now we have to do the rest of this question. It says, if the compound is soluble, list the ions present in solution. Now, C and D are not soluble, so there are no ions in solution. Now we'll read that maybe a very, 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 very small amount of these insoluble solids will dissolve. But for right now, if it's not soluble, I'm not going to get many ions in solution, so I can't break it apart. It does not break apart. Soluble means it breaks apart into its ions. Now for lead acetate, there's one Pb, and as you can see with the subscript on the outside, there's two C2H3O2 minuses. So it's going to be Pb2 plus, and then C2H3O2 minus, C2H3O2 minus. These are all the ions that break apart. And then you saw in a homework question, what if I said I had 1 molar lead acetate? What if I said I had 1 molar? What would be the concentration of just acetate? Well, as you could see, when this breaks apart, I get 1 lead and twice as many acetates. So if I have 1 molar of lead acetate, I would have 2 molar of C2H3O2 minus, because I'd had twice so much concentration. That's just an aside to go with your homework. And then finally, NH4S. There are 2 different ions here. If that breaks apart, I get NH4 plus, which is ammonium. And then I have S. Oh, this is written incorrectly. This should be NH4 2S. That's my mistake, and I might have mentioned this in class. All right, so I have NH4 plus, another NH4 plus, and then S2 minus. All right, so this formula was incorrect, and so we fixed it. This is ammonium sulfide. That's the name of this. How did I know to fix ammonium to have 2 of them? Well, sulfide typically forms -2 charges, and ammonium has a +1 charge. So I needed 2 ammoniums to get 1 sulfide. And so again, if they dissolve, I'll have twice as many ammoniums as I do sulfide. If I had 1 molar of NH4 2S, I would have 2 molar NH4 plus, and then 1 molar S2 minus. I have twice as much NH4 plus that would break apart in solution than I would S2 minus. Okay, so I wrote a lot here. I'm going to try and separate this with a line. All right, so let's put this like this. And I'll put this like this so you could see all the stuff that I wrote. So again, A and B are soluble. Acetates or C2H3O2 minuses are all soluble salts. Ammoniums are all soluble salts, so both these are soluble. These two form insoluble salts. And we're going to eventually do notes on how I could tell the difference and how I could write all these different breaking aparts of ions. So you could use this to kind of help you with your answer key and checking your answers to this entrance task.